There is a seed that contains more protein per ounce than beef. It thrives in heat that turns corn into dust. It grows with almost no water in deserts where wheat dies within weeks. For 5,000 years, it powered civilizations across the hottest regions on Earth. Then, in less than a century, we erased it. We replaced it with crops that require constant irrigation, buried its name in forgotten archives, and let it vanish from our fields. But beneath the soil, something was waiting. It did not die. It slept. This is the story of a food so resilient it outlived empires, and why removing it may become the greatest agricultural mistake in human history. Welcome to Lost Archives. The story begins in the Tehuacan Valley of Mexico, an archaeological site dated to 500 BC. Inside ancient storage pits sealed for 2,500 years, researchers found seeds perfectly preserved in clay vessels. But what really stunned them wasn't the age. It was that these seeds should have been dead. Every agricultural model said they shouldn't germinate. But genetic analysis revealed the story goes back even further. This seed was domesticated 5,000 years ago in a single cultivation event in the Sonoran Desert. The people who bred it had no written language, no laboratories, no modern science. But they possessed wisdom we have lost. In a landscape where survival meant choosing what to plant before the rains came, they chose this bean over grain. Not for sentiment, for survival. This is the tepary bean, scientifically known as Phaseolus acutifolius. Evolution engineered it for one purpose: to live where nothing else could. Its genome is a biological fortress. The plant produces specialized amino sugars that prevent its proteins from degrading even when air temperature reaches 118 degrees Fahrenheit. When rains fail, its leaves fold during the day to conserve moisture, opening only at night when temperatures drop. It fixes atmospheric nitrogen, healing depleted soil instead of extracting nutrients. And it produces more protein per ounce than beef, up to 25 grams per 100 grams of seed. The Tohono O'odham people called it bavi, simply a bean. But their oral traditions tell a deeper story. They say the Milky Way is not made of stars. It is made of white tepary beans scattered across the night sky by the Creator. That is how abundant it once was. 1,000 years ago, the Hohokam civilization cultivated tepary beans throughout what is now Arizona, using methods that defy industrial logic. To them, abundance wasn't measured in yields. It was written across the sky. They planted along Tehuacan Desert washes, bone dry most of the year, then briefly transformed into fertile channels when the monsoon rains surged through them. They built brush diversion structures to capture flash floods. The beans germinated with a single rainfall and matured in just 60 days. 2 monsoon storms, 1 complete harvest. In regions receiving only 3 inches of annual rainfall, the tepary still produced full crops. By the 1920s, Tohono O'odham farmers were growing 1.5 million pounds of tepary beans annually. They traded them across the Southwest in networks linking Arizona, Sonora, and the Great Plains. The bean sustained entire communities through drought, famine, and heat that killed European crops. And it kept them healthy. Before processed foods arrived, the Tohono O'odham had virtually no incidence of type 2 diabetes. Their traditional diet of tepary beans, mesquite pods, and collar buds maintained healthy cholesterol and balanced blood sugar naturally. The tepary was central to this. Its soluble fiber slowed digestion dramatically. Its low glycemic index made it ideal for metabolic health. Modern research later confirmed something extraordinary. Tepary beans contain protease inhibitors that suppress growth of certain cancer cell lines. This was not just food. It was preventative medicine growing freely in sand. So how did a crop this powerful vanish? It was not drought that killed it, not pests, Not a disease. It was an ideology. The first blow came in the 1600s. Spanish Franciscan missions spread along the Rio Grande with a threefold objective: convert indigenous populations, pacify the land, extract resources. The missions brought wheat, barley, and European cattle. Native farmers were ordered to plant wheat for church tithes. Tepary beans, wild, uncontrollable, requiring zero European inputs, had no place in that system. A Jesuit journal from 1694 described the crop as too wild to control. Fields growing tepary beans were replaced or burned outright. European crops failed again and again during southwestern droughts. In response, colonists starved within reach of a food that could have saved them, not for lack of knowledge, but because it would not submit to their system. Even then, the bean did not surrender. Seeds remained buried in soil, dormant through centuries, waiting. By the 1930s, a different weapon emerged. World War II transformed the agricultural landscape. Farmers left subsistence plots to work for wages on large-scale cotton operations, driven by well irrigation. These industrial farms ran on machines: mechanical harvesters, tractors, monoculture designed for efficiency. Tepary beans were labor-intensive. Pods matured at different times, requiring hand-picking. If harvest came too late, pods shattered naturally, spilling beans onto the ground. A brilliant wild survival mechanism. A nightmare for mechanized agriculture. In a system built for speed and uniformity, the tepary had no place. Government subsidies flowed to corn, soybeans, and cotton. Crops that fed livestock, not people. By the 1950s, the tepary bean was nearly extinct. In less than 20 years, 5,000 years of agricultural intelligence vanished. But a handful of families refused to forget. Ramona Button of Ramona Farms discovered beans saved in an old trunk by her grandmother. Seeds that should have been lost were kept like sacred heirlooms, tucked in clay jars, hidden in basements, passed down with whispered planting instructions. The bean was waiting for the world to need it again. That moment arrived in the 1970s. Global droughts struck hard. Soybean yields collapsed. Corn struggled to pollinate under relentless heat. Even wheat showed fatal weakness under 110 degrees Fahrenheit. Farmers across the American Southwest grew desperate. Agricultural researchers began testing wild plants still thriving in desert conditions. What they found astonished everyone: a vine with small white blossoms growing vigorously at 115 degrees. They planted experimental plots near Tucson and Sonora. Even with almost no irrigation, it produced complete harvests. The plant was the tepary bean, alive and productive after 4 centuries of systematic erasure. Scientists measured soil nitrogen after harvest. Levels were higher than before planting. The plant literally healed the depleted earth. A USDA researcher named Dr. Howard Scott called it a gift from the past to the future. Comparisons to soybeans were striking. Tepary delivered 20 to 25% protein, resisted pests naturally, and needed only 1/3 the water. This was not a relic. This was a survivor designed for extremes. But survival alone does not guarantee revival. The tepary had everything industrial agriculture claimed to want: high yield, drought resistance, natural soil regeneration. But there was one fatal problem. It refused to belong to anyone. You cannot patent a 5,000-year-old landrace. You cannot genetically modify it to require proprietary inputs. You cannot sell expensive fertilizers alongside a nitrogen-fixing legume. And that made it invisible in a system built entirely on control and dependence. Today, climate models warn that over 30% of global crop yields could collapse by 2050 due to rising heat. Yet the tepary bean has already survived worse. It was born from heat, bred in conditions where corn and soybeans wither and die. Scientists now call it America's survival crop. In 2019, university trials in Arizona and Mexico confirmed what desert farmers always knew. Tepary beans used less than 1/3 the water of soybeans while producing nearly equal protein. That means they can feed families in regions where rainfall barely touches the soil. The International Center for Tropical Agriculture in Colombia is now testing crossbreeds of tepary and common beans to impart drought and heat resistance to global food systems. The story of the tepary bean is not about rediscovery. It is about recognition. The knowledge was never lost, only ignored. And now, while the world spends billions engineering drought-proof seeds in laboratories, the answer has been waiting in the desert for 5,000 years. The bean that survived conquest, mechanization, and corporate erasure. It never stopped offering its gifts. The question now isn't whether this bean can survive climate collapse. It already has. The question is whether we will choose it or repeat the same mistake. The crop we called backward may be the future of survival. If this archive opened something for you, subscribe to Lost Nature Archives and hit the bell. Every like and share preserves what they tried to erase. The next archive opens soon.